It's Sunday, March 9th, and kind of a late start today, around 12:30, but no big deal. The interesting thing, I left these balancing overnight, and it completed the balance, so it's just has the status light on now. But actually, two different cells now are the max and min, and every cell now is at 3.78. So very precise balancing. Pretty cool to see that just happen overnight. Today's work basically was just looming stuff. It's very time consuming, but it's extremely important. You can't have exposed wires running around, and it just makes it easier to see. Probably going to need to loom this, because it is high voltage, but anyway, that is the inverter ignition relay. Have not hooked up the high voltage yet, but I loomed it, taped it, don't denote it's orange. Same thing here. I did decide to put the high voltage sense wire in the main HV loom. I just felt like it would be too complicated to run another tube, corrugated tube. So it does go through here, this box, but I'm okay. I mean, it's on this side away from the ground, so I could even like loom it in there. Might probably be judicious, prudent. So we kind of like arranged it that way. I don't know if it will secure the same way, but it just seems like this tube it's too hard to come up and then make a full 90 degree in. It really wants to kind of curve around. So, and then there is this loom attachment there, which is stock. This wire has some flexibility. So anyway, I think we're going to go with that. Again, that is not live right now. I mean, this plunger is up, number one, so it's breaking the ground, the packed ground. But one thing I did find out is that there is a few millivolts of power between the red and black wires of voltage. So, and that is just simply voltage leakage across the contactor that's in here. Working at Tesla, you get some experience, or at least the idea of the idea of a fused contactor. So if it's just not completely open, like maybe there's a little bit of corrosion or something, because it is just a relay, it could be close together. It's really probably not too much clearance, and then if there's any corrosion, you're still going to have a circuit path. So that's that. There is actually some voltage, but it's not a lot, and it's taped off, and that's okay. I'm running the loom underneath the seat belt alongside the seat. Again, this seat does not slide, but we had some luck here kind of finding a spot to secure this. There was a bracket here for, I guess, the tunnel panels, but for now we're going to use that as our point of retention. Also, this here is interesting. I just thought that it would make sense to secure it before it goes outside. And then again, kind of like using the tunnel to get it up rather than just like up and then a sharp curve there. I think I'm gonna tape these off with butyl tape. I went with the higher one because this is at kind of like an angle. So just for water ingress, I thought it would be best to use the top one just because it's parallel, and then tape off the bottom. But there is a possibility of water entering this corrugated tube, and then this part of the tube from here back is not split. I was able to just send the wires through the tubing for about 5 feet of it, and then it just stopped, so I had to split it open to pull it through, but that's why I taped it. Just have to like think about water getting into the corrugated tubing. I also, when I use this wire, I don't know why, I just cut it too short, so it stopped basically like here. So always measure more than you need. You'll be surprised when the harness kind of does its loop-de-loops and up and down how much more you need. If you just run, you know, from there to here, you're actually going to need another 5 feet once it's done doing all its turns. But this is okay. Coming through the bulkhead and taped up. I think we're going to go with this setup. This is just a board that I had to cut it with just tiny little hacksaw, super hacky. But maybe I'll paint it first before I put it in with the primer, just to make it all one color. And it looks like this is going to be the orientation of the inverter. It's not ideal, but you can kind of see that it kind of like swoops up like that. So like this is the low end. So that's kind of the front. Like if you're looking at an aerodynamic point of view, that's the orientation. So basically, you know, we've got the high voltage would have to come in here, and then the 3-phase would go out here down to the motor. Yeah, it's not the best, because if, you know, you got in a crash, the radiator would be pushed in, but I'd rather it be shorting out on the 3-phase side than the batteries, the HV side. So I think this is best to have this room here. But yeah, the wires are going to kind of have to like come around and then down and then in. And these ones are going to have to kind of come up and in. So, but it is kind of nice. You can see the motor still with kind of this shape of board. I'm just happy I had something that was pretty much exactly what I needed. It fits the width even this way, so I can secure it down. It looks like I'm going to go with, you know, the coolant ports on this side, but maybe flip them on the other, because if this is the side for the logic connector, like I could turn the coolant pipes, the coolant ports around on the other side. No big deal. It would just mean I'd be running coolant kind of up and around and down. And the same thing with the water pump that's down there, be the same thing, kind of bringing it up, around, and then in. So, we'll have to think about that one, but I do like, if there were a coolant leak, that it be on that side and not on this side where you're gonna have a logic connector, because, you know, it could spray, just shoot right into the logic connector, or all the, you know, we're probably gonna need another box here for like all the junctions, all the low voltage junctions, because there's a lot. It's really not that much to, you know, but here is the connector, but you can kind of see some of them are very short, and so but some of them are long. This is the HV sense wire, but it should be orange. I don't know why they made it blue, but anyway, yeah, logic connector on this side makes sense. If I've got, you know, this is going to be our logic wire which is basically just contactor power, as far as I understand. Actually, no, it's also going to be the gauge. So this spyglass, it's got 4 wires going to it, so that's also going to be on that loom. You know, so I may even have the contactor power on its own loom, you know, and then just put the spyglass in here. I kind of like, you know, separating the harness into separate looms, because then you can kind of, you know, to a point, you know, you don't want 1,000 looms around, which is why I just kind of stuck with simplicity of one high voltage line coming in, which I think was appropriate. But yeah, it would be nice to see the water pump going, just to see if it's sealing all right. Here is the accelerator pedal, so that also is going to be going to the logic connector. So maybe we'll run accelerator pedal and spyglass in this one, and then for contactor power do its own smaller loom. Maybe send it down that one, because it's got to run back along, basically follow the high voltage, or run on this side, follow this white wire, because it is low voltage. But again, I'm kind of worried about any interaction between the inverter and the high voltage system and the low voltage system. I really want to try to minimize the potential for contact, just because, you know, say, listen, you got that high voltage sense relay, ignition relay for the inverter. It needs 12 volt control. I can show you, I loomed that up and it goes in, but what if that relay shorted out and now suddenly high voltage is going into the junction box over there? Everything's fused, you know, so hopefully, but, you know, current is one thing, voltage is another. Could have low current but high voltage, so, and it wouldn't pop the fuse, it would just wreck the electronics. Yeah, so like even like the contactor power thing, like I have to consider that as like a potential high voltage if the inverter internally shorted and suddenly I've got high voltage running on a low voltage control line. You know, I guess that's just the reality of electric cars. You know, any component that has high voltage coming in could potentially create a path between that HV to the low voltage stuff. Yeah, so definitely going to be working next weekend on this, but I think we're almost done like wiring everything up, and then if we can, you know, key on, put some coolant in this thing, see how we're going. I basically got 2 weekends left in March here before it's the end of the line, because soccer's starting, and coming in here on a Saturday 1 day a week just does not work. So I'm really going to try to see what I can do next weekend to get this done, get it on the road. Anyway, got some sleep last night, feeling a little bit better, and you know, it's just trying to make it purdy. You know, it's time consuming and not very technical, but it certainly is part of the design standpoint, where you want to run your wires, and it needs some thought just so that it's tidy and you know, and when it's not a mess, it's easy to diagnose and it's safer and it's just more efficient. So anyway, Geo Zanecchia for Geo Rides on YouTube, and converttheclassics.com, 1975 Alfa Romeo Spider, electric conversion. Wish us luck.